This is 2.3, which is factoring, which is my favorite F word. I love factoring. Your notes from 2.3 don't talk about things like this because you're supposed to remember how to do them. So I didn't talk about them. This does say there's a lot of things you're supposed to do. You're supposed to find all the zeros by factoring. It has to be by factoring and using the zero product property. That's what ZPP stands for. And everything has to be in the form ax squared plus bx plus c equals 0. 0 can be on the right or the left, doesn't matter. I'm going to do 3. It's supposed to be an easy one. I'm going to move the 48 over. And then I'm going to pull something out. And I'm also going to change the number to a 64. There's a reason for that. Now it's set equal to 0. If I pull a 16, I get x squared minus 4 equals 0. Now, there's a couple ways of doing this. You can memorize a squared minus b squared is a minus b times a plus b, which is how you're supposed to do it. Or you can rewrite as x squared plus no x minus 4. It doesn't really matter how you do it. You're going to get the same thing. You are. 16 stays there. This would be a squared. This would be b squared. So to create an x squared, a has to be x, a minus b, a plus b. And to create a 4, b has to be 2, plus or minus 2. And you just use your cover-up technique. X plus 2 is 0, x minus 2 is 0. So x plus 2 is 0, which means x is negative 2. There's an answer. Or x minus 2 is 0, which means x equals 2 is an answer. Now, hopefully you can kind of see here that when I think of it like this, I'm thinking factors of negative 4 that add to 0. That's kind of what I'm thinking. Factors of negative 4 that add to 0. So plus and minus 2. That's how you do it. 2 needs to be changed to that. And I didn't do one of these. So these are actually really simple. I can pull a 3x from both pieces. If I pull a 3x from 9x squared, there's a 3x left because 3x times 3x is 9x squared. If I pull a 3x from 3x, there's a 1 left. Minus because there's a minus. Think about the distributive property to get that back. What I have here by the zero product property is that 3x is 0 or 3x minus 1 is 0. Now this has to be 0. It literally is the zero product property. X has to be a 0. This is a two-step equation. 3x is 1, divide by 3, and x is 1/3. Now, pause this real quick and make those changes to the document while I'm thinking about it. Now, I made this one straight from my head. I didn't look at an answer. I didn't look at the book or anything. I just made these up, so everything may not be what I intend it to be. And now I've learned that I also need to change 4. Wonderful. Okay, so I'll change that in a little bit. 4 has to be changed. Let's look at 5. I've got a little hint there. It says might shift everything right. I'm going to shift everything right on it because what that does is that changes all these signs. Makes it easier to handle too. And now I'm going to use the guess and check technique. You know, how do I want to make a 6 and so forth? And I think there might be a mistake in it as well. I don't know. No, there's not. To make a 6a squared, it takes a 3a and a 2a. Could also be a 6a and a 1. And factors of 25 are 5 and 5. Now I'm going to check myself here. That's 15a. That's 10a. And that's my goal. My goal is 25a plus plus. Quantity is still equal to 0, so now I get to use zero product property. 0 is 3a plus 5, or 0 is 2a plus 5. These are both two-step equations. We subtract, and then we divide. This will be a is negative 5/3 when everything is said and done, and this will be a is negative 5/2 when everything is said and done. So, two answers. Nothing wrong with 5. Anything else look interesting on this? I really want you to do the majority of the factoring by yourself. So I'm going to stop there. That was 3 factoring examples of 9, third of them. You need to practice the rest of them. You do. I have spent more time on y'all. I have probably got 4 times the amount of work that I'm doing for your group than I did last year's group. I'm probably doing 10 times what I did for the group before that, as far as all this extra stuff I'm doing, recording the videos and stuff. Probably 20 times the group before that, and I'm getting less out of y'all. Like, it's sad. Y'all need to wake up. I'm getting frustrated. All right, I'll do 12. You're supposed to write the factored form of a quadratic given its zeros and an a value. And the form here that you're using is f of x or y equals, who cares, a times x minus p times x minus q. Where these are your x-intercepts or zeros, roots, whatever. Okay? So this will be p, this will be q. And I gave you a. So anyways, the form here is f of x is negative 3 times x minus 2, see how that works, times x minus 1/3. Now that is the factored form. I did that part. Then write it in standard form. So here's part 1. Part 2, we actually have to do some math. Let's see here. I'm going to do a little trick here. I'm going to write this down and show what I'm going to do. I'm going to take that 3 and I'm going to move it into this second set only. You only move it into one set. There's a negative out front still because I didn't move the negative. 3 times x is 3x. 1/3 of 3 is 1. That's why I did it. Because it's going to make the double distributive property a whole lot easier. All right, now we're going to do the double distributive property. If I x 3x minus 1, I'm going to get 3x squared. By the way, that parentheses is still needed. There's still a negative symbol. X times the negative 1 is minus x. Negative 2 times 3x is minus 6x. Negative 2 times negative 1 is plus 2. And the last thing to do is to distribute that negative. So negative 3x squared. This was negative 7x. Now it's positive 7x. And then minus 2. I'm only going to do one of those. Figure out the other two. 13, 14. If a quadratic has x-intercepts at negative 1/2, 0, and 2, 0, then what? X-intercepts are synonyms of zeros or roots. They mean the same thing. Zeros is what I'm after. If I have an x-intercept of negative 1/2, 0, then f of negative 1/2 must be 0. Remember, this is x, this is y. That's how function notation works. And f of 2 must be 0. If you can do that, I mean, if you can't figure out 14 after seeing one example of 13, I cannot help you. Can't do it. All right. Looking the other way around, 15. If f of 1/2 is 0 and f of negative 3 is 0, then a quadratic has x-intercepts at blank and blank. Remember, this is x, this is y. This is the ordered pair. Give me a second. 1/2, 0. That means this is the ordered pair, negative 3, 0. Got to knock at the door. Got to pause. I'll be right back. All right, where was I? All right, we got a little trig. I'll do one of them. They are different ratios. And so there's that. Think about that. Of course, I'm going to write down SOHCAHTOA, which is something a lot of juniors are leaving blank on the form quiz. Blows my mind. Now, this talks about assuming an angle lies in different quadrants. I know what you were taught last year, and you weren't taught really trigonometry as it's supposed to. You were taught triangle trig. All right, that's what you were taught. Trig is way, way more than that. They're saying assume the angle lies in quadrant 4, which should be this guy right here. That's where she lies. All right, that means that's where I'm going to draw the triangle. Now you have to draw a triangle in such a manner that the right angle is formed with the x-axis. Has to be done that way. I'm going to throw angle A in the corner. Sine ratio, according to SOHCAHTOA, is opposite over hypotenuse. So opposite is a negative 3, and 7 is the hypotenuse. Now, there wasn't ever really a triangle there. Nobody is saying that we have a triangle of length negative 3. The triangle is to get you with what you're comfortable with. You're comfortable with triangles. I want the tangent ratio. The tangent ratio is going to be opposite over adjacent, which would be this guy right here, and I don't know what she is. So I'm going to do a little bit of Pythagorean theorem. A squared plus b squared is c squared. I have no idea what this leg is. So a squared plus, this is a negative 3 squared, must be 7 squared. Now 7 squared is 49, 3 squared is 9, subtract 9, a squared is 40. I do not want your decimals, and nobody does. A is the root of 40. Here's something that kids are horrible at. 40 is 4 times 10, which is 2 root 10. Every time I do this with kids, they're like, I've never seen that in my life. Bull crap. You go tell Miss Garner that you've never done that, and she will laugh at you because she did it with you. You go tell Miss Cantrell that you've never done that, and she will laugh at you because she did it with you. Anyways, opposite over adjacent, negative 3 over 2 root 10. Oh, but wait, there's more. It is not formal to leave radicals in the denominator, so we multiply top and bottom by root 10, and we get negative 3 root 10. Root 10 times root 10 is 10, times 2 is 20. So negative 3 root 10 over 20 is my final answer. It's kind of hard to see it. Final answer. The tangent of angle A is negative 3 root 10 over 20. Now there are some shortcuts to this, but you don't know them. So I can't teach them, because if you don't understand this, you're not worthy of the shortcuts. All right, what do we got going on here? Let's look at 20. Quadratic has 1, 0 at x equals 2. It passes through the point 3, negative 4. Actually, that one's too easy. I'll save that for you. 21. Quadratic has 1 x-intercept at negative 3, 0. It passes through the point negative 2, 2. Write the factored form. You must find A, the vertex form, and the standard form. So again, factored form is f of x is a times x minus p times x minus q. It says it only has one x-intercept. Huh. That's just weird. Think about that. If we only have one x-intercept and we pass through the point negative 2, 2, we'd look like that. What happens is this guy happens twice. Happens 2 times. So, taking away a negative 3 has to happen twice. By the way, taking away a negative is positive. Now I'm going to plug in what I have. I've got a point which gives me an x and a y. 2 is a times negative 2 plus 3, because taking away negative is addition, times negative 2 plus 3. 2 is a times 1 times 1. Well, this just tells me that a is 2. So, my factored form, I got tired again, is f of x is 2 times x plus 3, written twice. That's my factored form. Vertex form is really easy on this one. F of x is 2 times x plus 3 quantity squared. That is vertex form. Vertex form is f of x is a times x minus h quantity squared plus k. That's vertex form. It's done. And the last thing I got to do is standard form. So I'm going to do the math on this right here. X times x is x squared plus 3x plus another 3x plus a 9. And then I'm going to double everything inside. 3x and 3x is 6x times 2 is 12x. Oops, that should be an 18, not a 19. And that's where I'm going to stop. That's a good chunk. I pulled ACT off for a little while because I need to cover some content. So I'm just giving you all a small break from it. It'll come back when I'm ready for it.